Welcome to this session on securing the cloud operating model. My name is Vinay Venkatraghavan. I'm part of the Office of the CTO at Prisma Cloud with Palo Alto Networks. I wanted to provide a little bit of context as to why we're seeing a dramatic increase in the adoption of cloud and cloud native technologies by a lot of our enterprise customers. It's no secret that the cloud is modernizing the software development cycle. So what that means is enterprises are driven by the sheer need to bring more and more innovative applications for their end customers to the market at a much more rapid rate. So they've resulted in abandoning the waterfall processes of the past and adopting more agile methodologies wherein they can truly realize this end goal of developing and deploying and bringing together these innovative applications at a much more rapid rate. Secondly, there is also the recognition that they need to break up monolithic, tightly coupled, and vertically scaled applications into their constituent and composite microservices so that pizza teams can independently deploy, develop, manage, and scale independent applications. And this affords much more agility than to actually when the software was actually deployed as a monolithic application. The third pillar of this transformation is also the move from batch releases, wherein software was released maybe twice a year, to a more DevOps kind of a process, wherein they're able to release software multiple times a week. And dare I say, some of the mature organizations we've seen are actually deploying software multiple times a day. And the final component of this transformation is that enterprises are now leveraging a common cloud operating model and going away from custom, manual, customized scripts to being able to represent all aspects of their infrastructure as code, and now leveraging these kinds of automation capabilities in modern CI/CD pipelines to deploy, bring up, tear down, and make changes to their software deployments at a very, very rapid rate. And this is also the added benefit that infrastructure as code now allows DevOps teams to actually treat their application deployments as cattle and not pets. So this has completely transformed the way enterprises are adopting and leveraging clouds for their line of business applications. So as part of this transformation, there's this concept of the fundamentals of the cloud operating model that has actually a message that has actually been amplified by HashiCorp, wherein they break down these different phases of developing and deploying software. The first phase in that model is the provision phase, where you're leveraging infrastructure as code, automation to actually have reproducible and repeatable architectural deployments on clouds as well as multi-clouds. And so this tremendously benefits the deployment of new software at a very, very rapid rate. The next step in the cloud operating model is the process of connecting these applications. As more and more applications are decomposed and deployed as microservices, there needs to be a capability which provides automated service discovery so that these microservices applications can seamlessly discover the components that they need to communicate with, and can leverage automated and connectivity information to make sure that they are connecting appropriately with the services that they need to communicate with. The final piece of this puzzle is also called the run phase or the runtime, where you need to have deployments that are very, very scalable and elastic to meet spikes in demand, for example, where infrastructure scales to meet spikes in demand and then scales back when you resume normal operations. So you always need to ensure that your applications are highly available, and then you can also perform upgrades to new versions of your software in a highly seamless manner. So when you put all of this together, this is what the cloud operating model looks like. I'm going to start with this concept of shift left. So on the left, what you see is various providers that Terraform provides, if you will. It's highly pluggable system. So you have cloud providers, for example, AWS has the providers where you can actually represent all of your AWS infrastructure in Terraform and deploy complex architectures on AWS using Terraform. Similarly, as we go up the stack, Palo Alto Networks was the first security vendor to develop a security provider now, wherein as DevOps teams and SecOps teams are deploying and developing their cloud architectures and applications and representing them as infrastructure as code, with the Palo Alto Networks Panos provider, now security teams can also represent all aspects of their security policies and configuration as code and deploy it along with their application deployments to ensure that they have zero trust and the appropriate levels of security. And similarly, as you build up the stack and you're building out your virtual machines, your subnets, your hosts, etc., you keep adding on to the level of abstraction. Now you can actually deploy Kubernetes across a multi-cloud environment using Terraform. And the final piece of the puzzle is using application manifests in Kubernetes to deploy large-scale microservices-based application on these cloud platforms. However, the problem is that with a lot of this innovation around automation and cloud native deployments has come with it its fair share of security threats and vectors. So I wanted to quickly just provide a bird's eye view into the various threat dimensions that face cloud native applications. So let's start, for example, with the host. When you deploy cloud instances, there are a whole bunch of OS packages, if you will, which potentially have a whole bunch of vulnerabilities. Similarly, there could be malware that is present in a lot of these packages. And similarly, now as you actually go out of the host layer and into the network layer, you want to make sure that as you leverage infrastructure as code, that you're not overexposing your application networks. A simple example is to make sure that your EC2 instances or your Azure instances are not open to the entire internet over SSH port 22. Or for example, if your blob storage buckets are not exposed to the entire world, and to make sure that these blob stores are appropriately encrypted, etc. So there are a whole slew of threats that are on the host, the network, and then now we can also move to the Kubernetes orchestration platform, where you see that if the Kubernetes platform, which is a very, very powerful system, if it's not appropriately configured and secured, it dramatically increases the attack vector, where your etcd, which is the key value store that stores all the Kubernetes configs, can be easily exploited. Potentially a malicious actor can delete all the configuration, etc. So you want to make sure that you have the right security posture there. And last but not least is this very important dimension of secrets management. So we will talk a little bit more about all of these different dimensions as we progress through our presentation today. So when we take all of these different threat dimensions, let's talk about how and where they manifest. And in the paradigm of shifting left, I'm now going to talk about the runtime last, but I'm going to shift left and let's talk about where these threats precipitate. There has been an incredible explosion, and rightly so, of infrastructure of code adoption for automation-based use cases for cloud. However, the problem is that we've seen a tremendous amount of misconfigurations that precipitate in infrastructure as code that obviously gets transmitted into your runtime environments when you actually deploy Terraform templates. A couple of examples are, for example, when developers and DevOps teams deploy S3 buckets for storage needs of their applications. And more often than not, we find that these S3 buckets have not been encrypted. They're exposed to the internet. They don't have versioning. So these are all very, very fundamental compliance controls that you need to ensure that they're appropriately configured to validate the security of your application deployments. Similarly, in the same vertical of infrastructure as code, Kubernetes application manifests are naturally represent all of their deployments as infrastructure as code. Now, each application manifest contains a security component. And if you don't have the right security settings on these in your Kubernetes application manifest, it exposes your applications to malicious attacks and attackers. So for example, the threat vector here is if you have malware present in your container image, and if the container image is running as the root user, it is very easy to actually perform a container breakout, exploit the host, and potentially perform lateral movement and actually expel data. So now let's move to the container image aspect, where we've seen with the advent of open source software, and as DevOps engineers, and I'm just going to give you an anecdote of my own experience as a developer, where my goal is to meet the needs of my application and deploy and make sure that I'm meeting all the functional needs of my application. So I see a container image that has all the different libraries and dependencies and packages that I want to leverage for my application. And I download this container image to build my application and package my application. However, as a DevOps engineer, I don't have full visibility into all the vulnerabilities that are potentially present in all these libraries and packages, which could be easily exploited. So that's a very, very important threat vector that needs to be addressed. And similarly, I also talked about the fact that a lot of these open source software and container images that we download from public repos could potentially have a lot of malware that can render these application deployments in production runtimes extremely vulnerable to different types of attacks. Now, when we actually take this container image, it's actually pushed into the container registry. So there are specific controls that can be applied to a container registry, whereby you can impose the use of only sanctioned images and make sure that images that have not been scanned through your vulnerability scanners should never be promoted into your production environments. And similarly, you can also enforce these kinds of restrictions by using signed images. And then we talked about some of the threat vectors in the Kubernetes layer, where if you've not configured your Kubernetes API appropriately and protected with TLS and the appropriate level of authorization and authenticated access, a malicious actor could completely DOS and actually destroy your applications as well as your environment, causing a lot of potential harm to business assets. Similarly, aspects such as ensuring isolation between the host namespace and the container namespace is very, very important. These are all threat vectors that can be easily identified using various kinds of scanning techniques. And last but definitely not least is the runtime, where you have to make sure that you have the right compliance controls, security controls to ensure isolation, ensure that there are resource limits, that no runtime, process, file, and network protection, that in the absence of runtime, process, file, and network protection, your containers could actually be punching out to command and control centers and malicious domains and installing malicious software that can very easily exploit your runtime environment. And as I mentioned, from a network perspective, last but not least, if you don't have the right level of ingress and egress network protection, both from a north-south as well as east-west protection, your container environments, your microservices are left highly vulnerable. So this constitutes the cloud-native security threat dimensions and landscape. So I talked about the fundamentals of the cloud operating model, but now I want to shift that to demonstrate how we want to talk about the fundamentals of the secure cloud operating model, wherein we want to seamlessly integrate security throughout the provision, connect, and run phase. And over the next few slides, I'm going to talk about how security can be seamlessly and natively integrated through each of these different phases. And while we do that, I also want to talk about a very, very major shift, and it's very important as we leverage cloud and container native deployments. It's very important to actually shift left while runtime security is a table stake and that's never going away. There is a tremendous opportunity that we have as an industry wherein we can, with the right purpose-built tools, for example, from Prisma Cloud with Palo Alto Networks, you can actually shift left security, apply all your compliance and security controls in your build and deploy phases, identify these violations even before a lot of your assets are deployed into the runtime. This concept is called shift left, and examples of shift left are, performing your Git repo scanning with Prisma Cloud, wherein we can give you a full manifest of all the vulnerabilities that exist in your libraries, dependencies, and packages that are used as part of your applications. And you can build security compliance policies around that to ensure that highly vulnerable packages are never deployed as part of your applications in runtime. Similarly, we talked about vulnerability, and you can also enforce all your compliance controls in the build and deploy phase, in developer IDEs, and in the process of a modern CI/CD pipeline prior to the actual deployment of the software. And this kind of a posture tremendously improves the security of your applications prior to deploying them at runtime. And then you go ahead and secure your applications in the runtime, as we're going to talk about a little bit more very shortly. So let's talk about the first phase. This is called secure the provision phase. I talked about the dramatic increase in the adoption of infrastructure as code. So I wanted to give you a few examples and put that into context. So let's talk about Terraform. When you're deploying Terraform templates, we've seen so many violations in terms of security groups that allow internet traffic to SSH, or EC2 instances has SSH port open to the internet. S3 bucket encryption is not enabled. RDS event subscription is disabled for DB security groups. So all of these are fundamental practices that, when applied appropriately, can tremendously improve their security posture. And now we have the opportunity to identify, by performing a Prisma Cloud scan on your infrastructure as code templates, to identify these violations right then and there when the DevOps teams are developing these Terraform templates. Similarly, I want to talk about the attack vectors in the Kubernetes application manifest, where it's a big violation to run a container as a root user. But the problem is, we've seen this kind of a violation more often than not, unfortunately, as we see many containers running as a root user. And you can see how easily it is to exploit. Malicious programs and malware can exploit the root user, perform a container escape, and potentially perform a lot of havoc on your entire Kubernetes platform. Similar threat vector is allowing a container to escalate privileges, sharing namespaces, as we talked about, enabling root file systems and setting it to read-write. I mean, unless absolutely necessary, root file systems should be only read-only, and this prevents a malicious actor to actually run new malware on your file system. So you can prevent that very easily. So now we talked about all these threat vectors, and let's focus on the shift left and the build and the deploy phase, with security injected throughout the application lifecycle stack. So, we can perform the scanning of infrastructure as code, identify all of those compliance violations with the Prisma Cloud integrations right in your Visual Studio Code IDE. So as a DevOps engineer, this has provided me a tremendous benefit, where I can perform the Prisma Cloud scan. I see all my violations, I know how to fix them, and I can go and address it. Similarly, when you actually are performing the specifications in your Docker files, you can scan your Docker files for all the library dependencies and have a full manifest of all the vulnerabilities that are present in your application packages, libraries, and dependencies. And if there is a compliance, or if there's a violation from your vulnerability management policies, you can now fix them. So once you've fixed all of these issues, now you're moving into the deploy phase, where we can perform the scanning of your container images in the container registries, and you can apply more fine-grained, tighter controls, if you will, in the deploy phase, to ensure that you're meeting all the compliance, security, and vulnerability needs, vulnerability policies. Only when all of those policies have been met, and you've scanned your Kubernetes application manifest for security violations. Only when all the tests pass, let's say they're green, for example, do you actually promote this infrastructure into your runtime. And now you can also run the Prisma Cloud Defenders in your runtime environments to have uniform runtime protection for virtual machines, containers, and serverless workloads. Now that we have talked about the securing the provision phase by scanning your infrastructure as code templates, scanning your container registries, identifying all the vulnerabilities and malware prior to the deployment, let's now talk about once you've deployed your code, how do we secure the connect and discover phase? I'd like to now highlight a very tight integration between HashiCorp and Palo Alto Networks VM series firewalls for cloud environments. Now we're not only discovering, connecting, but we're also securing applications. The cloud is all about elasticity. It's all about infinite scale. So applications are constantly being deployed, torn down. So the whole system is in a constant state of flux. So any kind of manual intervention to be able to handle these kinds of changes is a recipe for disaster. Therefore, what we now are enabling with the integration between HashiCorp Console and the VM series is HashiCorp Console can seamlessly discover and identify new applications and services. Now it uses the discovered information and seamlessly programs dynamic address groups on the VM series firewalls. And these dynamic address groups, which have registrations of these new applications within the VM series firewall, and now all of these new applications are applied against a security policy, and automatically you have seamless connectivity and approved access between your applications. Just to give you a simple example, let's say that your database tier had only a single instance, DB1, and your application tier were communicating. But due to load, the DevOps teams have scaled up the database tier to now have another instance. Now, HashiCorp Console seamlessly identifies this new instance, programs the dynamic address group on the VM series, which applies the security policy. Now your application tier can seamlessly, app 1, 2, and 3 can seamlessly access your database tier without any manual intervention. This is a very, very powerful capability wherein when console and VM series work very closely in concert and provide automated discovery and security for applications that are running in cloud environments and running in a very cloud native manner, which means they are very highly dynamic and elastic. The final phase of the cloud operating model involves securing the run phase. So let's now talk about what this entails. Now, I want to talk about Prisma Cloud security for the runtime. The Prisma Cloud platform provides compliance and security posture management for all of your cloud assets. This includes IaaS, PaaS, as well as your DB services. With our newly vendored capabilities for data security, we are able to classify all the data into your S3 buckets and have a large number of classifications that we can identify. For example, personally identifiable information, social security numbers, credit card numbers, driver's licenses, etc. And to also give you a sense of what your posture is. As S3 buckets and cloud blob stores are being leveraged more and more, it's very important for enterprise teams to have full visibility into the data that is contained in there, as well as to the security posture of these S3 buckets. For example, as I talked about it, we make sure that your S3 buckets are encrypted, not overly exposed to the internet, etc. Additionally, from a runtime security perspective, the Prisma Cloud Compute Defenders can provide host, container, and serverless and uniform capability across the entire application stack to provide security from a runtime perspective. And what that means is the Prisma Cloud Defender automatically learns the behavior of the application. So, for example, you can build an automated model, and this is very, very important when you're talking about cloud and container scale. It's manual processes are just not going to work. So once a behavioral model is built, the Prisma Cloud Defenders know exactly what are the actions that are going to be performed by every single application container. So with this capability, they can monitor process and perform file integrity management, as well as ensure that the network accesses performed by different application containers is only sanctioned. And for example, if your application container is punching out to actually fetch code from a malicious repo, this kind of a connection will be automatically denied and protected against. And the other aspect of this is also the case for performing microsegmentation. It's no longer the case that when you have containerized applications, the perimeter is not the DMZ anymore, but the perimeter is the actual container in itself or the microservice. Therefore, we should only allow sanctioned allowed access and communication between microservices. Otherwise, your attack surface is unnecessarily overly exposed. So by this way, performing zero trust and microsegmentation, or your web tier, for example, can never talk to your database tier. I mean, that's automatically learned and seamlessly enforced. And similar concepts are applied across, as I mentioned, your host, container, serverless, across all these dimensions, from compliance, vulnerability, as well as microsegmentation and zero trust, and network security enforcement. So now I want to quickly pivot to talk about the secure secrets management with Prisma Cloud and HashiCorp Vault. This is a very, very significant collaboration between our two companies, wherein we help our enterprise customers enforce best practices and hygiene and good hygiene for secrets management. Too often we've found a lot of our customers, unfortunately, have a lot of secrets embedded into their application code. I mean, this is a very, very fundamental concept. Unfortunately, it's very, very prevalent in production running applications. So with the Prisma Cloud and HashiCorp Vault integration, what happens now is when an application developer does a kubectl apply command to create a container, Prisma Cloud seamlessly intercepts this call, identifies the secrets reference in your application manifest, fetches the secrets from Vault, and it performs just-in-time integration and insertion of these secrets into your containers to make sure that the secrets are only available to these containers for the duration of the application deployment. I now want to bring together all of these concepts that we've talked about and put it into the context of modern application deployment patterns and a modern CI/CD pipeline. So I'd like to call this Prisma Cloud Security for Public Cloud and DevSecOps. Let's once again shift left and start at the build phase, where we can now perform Prisma Cloud scanning for security and compliance violations right at the DevOps and the developer IDEs. You can scan your Terraform templates, you can scan your CloudFormation templates, etc., and identify all the different types of security violations and compliance violations that I've talked about. Once these scans have been performed, you can now move to right in the IDE phase of a developer and give them early and instantaneous feedback. Only once these scans have been successfully passed do you actually check in your code into an image registry or your source code management system. Once that's done, now we now move into the deploy phase. In the deploy phase, we have already built your container images. They are resident in a container registry. And just as you similarly do, I like to talk about the fact that you perform very, very sophisticated and in-depth testing from a unit integration system test, perform SAST and DAST testing. Now, security testing is also a first-class citizen in your deploy phase. You perform all the scanning of your images in your image registries. You perform the infrastructure as code scanning. You have very, very tight policies, because this is the last step prior to the deployment of your applications into your runtime. Therefore, you want to ensure that you're applying all the policies that you'd like to enforce from a runtime perspective. Only once, when all of these different artifacts have appropriately been scanned for security and compliance controls, and if it's successfully passed, do you deploy these artifacts into the cloud. And finally, In the run phase, we've already talked about how Prisma Cloud brings to bear a seamless security from a network security perspective. You can secure your network ingress and egress with the VM series firewall, seamlessly integrated into your security hub VPCs, for example. And the Prisma Cloud Compute data plane and the defenders are applied to bring together security for your virtual machines, your container clusters, integrated with HashiCorp's Vault for secrets management, as well as your serverless clusters to ensure that only sanctioned access and you have full control over the activities that are being performed across all of your different asset classes. And we also talked about the in-depth database data security features wherein we can perform full classification of your data storage buckets, provide visibility into the security posture of your data to ensure that you have the fine-grained security capabilities that need to be enabled to ensure that your data is appropriately secured. And finally, all of the alerts that are being generated from the Prisma Cloud platform can now be seamlessly integrated with the Cortex XOR platform for remediation purposes. The Cortex XOR stands for Security Orchestration and Automation and Remediation Platform. And we built a large number of playbooks which facilitate the seamless remediation for various different types of asset classes. And what that means is when an alert is raised, and if there's a playbook that is associated with the alert, you can perform automated remediation. And this is tremendously beneficial to help your security teams address the large volume of alerts that are typically seen and truly freeing them up to address the high fidelity alerts that potentially require manual intervention and forensics. I also want to start wrapping up by talking about this, one of the most powerful use cases of the Prisma Cloud platform and the Palo Alto Networks platform to address the cloud operating model and truly bring security integrated throughout the cloud operating model. And it all starts with your developer and your application team. I mean, one of the most fundamental activities performed by a developer as they're developing their features is making a pull request. So now what we have done is Prisma Cloud has out-of-the-box integrations for security scans in the pull request phase. So just like other testing is performed in the pull request, we can now perform security scans in your pull request. And if there is a security failure because there's some kind of a policy was violated, the pull request is immediately failed and sent back to the developer. So if it's failed, you provide instant feedback to the developer. So I talked about so many different examples, but let's just pick one of them. Let's say that you haven't enabled encryption on your S3 buckets. So this kind of a violation will now be instantaneously, this feedback is provided to your application developer. They have visibility into the security failures. They know how to fix it. Once they fix it, they can resubmit your pull request. It goes through your CI/CD pipeline, performs a scan once again. And if it's passed, you can actually merge your pull request into your source code management system. Then you move into the next phase. In the next phase, now that you've defined your Docker files, you've built your container images, and they are resident on container registries. With the Prisma Cloud scanning, you can easily scan all your container images that are resident in these container registries for the presence of vulnerabilities, malware, and apply your vulnerability policies. And so what you can see here, for example, at the top of this vulnerability listing, we have 6 critical vulnerabilities that are present in this image. So you could potentially have a security/vulnerability policy which says that any container image should not have more than one critical vulnerability. And if there's a critical vulnerability that has a fix available, that needs to be appropriately addressed before it can actually pass all your security testing. So similarly, if there are failures in the scanning phase using our Twist CLI scanners, automatically out of the box integrated in a modern CI/CD pipeline, it fails the build. It goes back to the drawing board to your developer teams. They address these fixes, update these packages, And only once all of these security failures have been addressed do you actually go and deploy your applications into the cloud. And the last comment that I want to mention here is also the fact that this is not a discrete event. The concept of DevOps and moving to DevSecOps by giving them purpose-built tools, it's a process of continuous improvement, wherein security teams have a very lightweight posture. They have full visibility into the security posture of applications, and they can actually team up with your DevOps teams, give them the visibility, enable them to take responsibility for security, and over time address their security issues and debt, if you will, and be able to identify, respond, detect, and adapt. And over time, this tremendously improves the security posture of applications that are deployed in the runtime. With that, I'd like to thank you very much for listening to my talk on securing the cloud operating model. And please let me know if you have any questions. We're always here to. Hello, everyone. I hope you can all hear me. Thank you. So I just want to take this opportunity to answer some of the questions that I've seen on the Q&A board, and I also want to open it up. If any of you have any questions, I'm happy to answer them at this point. One of the questions that I've received is, and I'm going to paraphrase a little bit on this one, which is pertaining to the pre and post pandemic era, when a lot of service and product providers are leveraging public and private clouds. The question is, how does one go about maintaining the security of their data, especially for maybe highly regulated industries such as healthcare industries? That's a great question, and it's obviously very, very significant because a lot of personally identifiable information is stored in our S3 buckets, and it's very important when we have to comply to healthcare standards like HIPAA, for example. It's required very, very specific compliance controls that need to be applied. So let me talk about three dimensions that you could potentially bring to bear to handle this kind of a scenario. The first, where I think it's very important to understand, is have visibility. So you need to have visibility into what kind of data is being stored into your S3 buckets. So Prisma Cloud has just brought to market this capability where we can classify all the data in the S3 buckets and identify these types of healthcare information and other kinds of. We have signatures for different types of data formats, which help you identify all the different types of information and classify all this data. So you can have full visibility, you can classify your data, and you can identify all the healthcare kind of information that is resident on these buckets. Once you have that, the next thing is to identify what the security posture is. From a security posture standpoint, a simple thing as ensuring that your buckets are always encrypted, and ensuring that you have the appropriate logging, full visibility into who accessed the data, how was it accessed, where was it accessed from. So having a full audit trail is very, very important. Enabling versioning. And another example of a security / compliance control is to make sure that your S3 buckets are not overly exposed to the internet, where now you have sophisticated hackers who are constantly performing a kind of scanning of open buckets, etc., to be able to very, very easily expel that data. So that's the next dimension, where you now have visibility into what data you have. You're applying the right security controls to make sure that data is secure, and then using a combination of these kinds of techniques, you can ensure that your applications can safely address the data security issues as you leverage public cloud storage mechanisms for a lot of these use cases. And the next question that I have is vulnerability scanning for container registry done when the containers are at rest or in the run status? Is Prisma Cloud performing an active penetration testing to identify vulnerabilities in these containers? So, we take both approaches. we also constantly and periodically scan your containers that are running in the runtime environment to give you full visibility into all the packages that you have deployed. Now, when you have full visibility into packages, we scan these packages for the presence of any kind of vulnerabilities, and we give you that information out of the box. But now, we also, with the adoption of containers, one of the biggest advantages that I see is the ability to shift left. So now you have these container images that are resident in container registries. And so you can scan the container images, one would argue, even prior to the deployment, and you can apply your compliance and vulnerability policies. And if you find any kind of compliance or a vulnerability policy failure, you can ensure that those images are never promoted into your runtime environments. So you can do both. So a long answer in that is you can apply different types of policies. You have telemetry coming in from both the shift left aspect as well as your runtime to actually have full visibility and apply the associated policies to suit your enterprise security outcomes and use cases. So with that, I'd like to just say I'll be here for the next a few minutes. So if you have any questions, feel free to post them once again in the Q&A chat box, and would be happy to answer them. So another question that I typically get also is that, how does, we talked about it already, but how do you weave in security throughout the entire cloud operating model? The cloud operating model is all about, the provision, connect, and run phases. And it's all about making sure that security is natively integrated. So in the provision phase, I mean, these are the fundamental building blocks where our DevOps teams are leveraging infrastructure as code to deploy, large scale out applications. And, we have this tremendous opportunity to be able to scan these templates for so many types of compliance and security violations. And this is a tremendous benefit. And I've had the privilege of seeing both sides. I built large scale cloud applications, deployed and run them, but I've also been on the security side of things. So I see both sides, and just giving the DevOps engineers and the perspective that, we've always talked about this friction between SecOps and DevOps. And I think that really happens because security teams are more often than not brought in at the last minute. So once the DevOps engineers have deployed their code, they moved on to their next feature because they have to be moving at a very rapid pace to deploy innovative applications. But the security teams now are engaged, and they perform a lot of these scans and come back maybe 2-3 weeks later. And now the DevOps engineers have no context. They moved on. And that's where the friction is. And that's where this concept of, SecOps is always reducing the agility of DevOps teams. But now with contextual security information provided right then and there when DevOps folks are developing their code or infrastructure as code templates, I mean, there is a far greater appetite to make sure that all the violations or the bugs, and now security bugs, and security is treated as a first class citizen, is addressed, and it dramatically improves the security of the applications that are deployed, because now you address security failures while you're developing the feature. It is not bolted on. It's integrated throughout the process, and that's a tremendous benefit. And then just want to reiterate, in the connect phase, I mean, clouds are incredibly dynamic. And I've seen this too, where I've deployed large scale applications. Any kind of manual intervention is just a recipe for disaster for your operations team, and it can lead to a lot of error prone actions, which could potentially have drastic ramifications. So seamlessly being able to react to new applications being deployed using services such as console to be able to discover these new services and then seamlessly use the integrations between console and the Palo Alto Networks VM series firewalls to apply the security policies for pertaining to those new applications, and to make sure that the connectivity between your different microservices are maintained in a highly automated manner with fine-grained security capabilities, once again, is a tremendous win-win. And then, of course, we talked about in the run phase where you can use automated models. It's all about automation. And so how can we bring automated security capabilities? So Prisma Cloud Compute Defenders automatically learn the behavior of your applications and are now able to apply and alert you on any abnormal actions that are taken by your containers, and you can take the necessary remedial action. I also have one last question I think I can take right now, which is, why is it not suitable to just scan the source code for vulnerabilities? Why do packages and other steps along the DevOps processes need to be scanned? So it's a good question. I think this goes back to the maturity of organizations. So just to give you a snapshot, we have a lot of code and we have a lot of new applications being deployed. Mature organizations can most certainly perform the scanning for all your vulnerabilities, packages, etc., identify the vulnerabilities and make sure that you have the right fixes available as the situation demands. If you have that, you can most certainly perform that in your source code management systems, your modern source code management systems, which have the ability to scan and have integrations for Prisma Cloud to be scanning a lot of these source codes right in your source code management system. But there is also a lot of code that is already being deployed where you potentially have a lot of vulnerable packages. You don't have the necessary visibility. So the problem is different teams are at different levels of maturity, and if you're at the ideal level of maturity, then you can definitely perform, and one would imagine identify a lot of your security violations, vulnerability management activities right in your source code management system, even before you've actually promoted that in the runtime. So it all goes back to the maturity of different organizations. So we'd like to give the necessary flexibility to address all the needs for different types of organizations to suit their specific use cases. All right, everyone. I don't see any more questions. So what I'd love to recommend as a call to action and a next step is, please visit the Palo Alto Networks and